A variable term is called a variable because variable means to change. And so variable terms change. X can stand for any number. So that's an example of a variable term. Or it could just be a y by itself. Or it could be a 2z to the third or something. These are all variable terms. Is called a constant because it's never going to change. It has a value that never changed. So in other words, a constant is just a number. There are no letters. So 10 is a constant. Negative 75 is a constant. 322, constant. Okay. So when you hear constant, it just means a number by itself with no variable. Okay. Like terms have the same variables and the same exponents, okay? And so they are the exact same. Okay, so 3x, y, and 2z to the third, these are not like terms, right? Because x, y, and z aren't the same. A coefficient is a number on a variable. So this is the number attached to a variable. So if I have, say for example, 6x, 6 is the coefficient. Yeah. Yeah, exactly the same thing. All right, we'll just go with it. Oh, I like terms. I'm going to make a like and unlike chart or table. Okay. Like terms have identical variables. So 2x and 3x would be like. Two x and 4y would be unlike.
How about we have 2xy?
Those would be like. They both have to have the exact same. Also, exponents. So if I have 2x squared and 5x squared, those would be like. That was a terrible straight line.
That's because you're going to add or multiply later the like.
Okay. Now, unlike 2x and 3x squared, they're both x's, but the exponents aren't the same. So they're not alike. 5 and 6x. A number and a variable term are not alike, so they cannot be combined. Like you can't add and subtract these. Okay, so just know that if you're talking about like terms, that variable part has to be picture perfect match. Exponent and letters. Okay, so let's look at the terms. My terms are 14x to the cubed, negative 6x squared, because it's minus 6x, which is the same thing as negative 6x, 3x, and 5. These are my terms. Okay. My coefficients are 14, negative 6, and 3. 5 is not a coefficient, it's a constant, right? Okay. When I look at this list here, my like terms are just the x ones. So I have negative 6x and 4x. Yeah, constant is a number just by itself. And then D. Are these alike?
No.
No. Because the exponents don't match, right? Now that's, sure it's a 2, but here the 2 is on the X and here the 2 is on the Y, so it's not the same thing. It has to be like picture perfect the same. The American Heart Association. That's a group, right? Associations are groups. And the associative property is just changing the group. So if we have some people A, B, and C, and A and B are in a group together, but then I switch it around and put B and C in a group together, did the total number of people change? No. Nothing changed except how they're grouped up. And that's how associative property works. It doesn't change the total number when you add it all together, it just changes the groups. So if you want like a concrete example, if I said 1 plus 2 plus 3, and then I did 1 plus 2 and then plus 3, this is 1 plus 5, that's 6, and this is 3 plus 3, it's 6. Not, the only thing that changed is the parentheses moved. Well, it's the same thing with multiplication. If I multiply A and B together first and then multiply it by C, it's the same thing as if I multiply B and C together first and multiply it by A. Just to prove that, no, not 2. I'll use 2 again. This is 6 times 4, that's 24. This is 2 times 12, it's also 24. So you can change the groups. I was supposed to put that over here. Okay, these were supposed to be over here where it would look all pretty. Sorry. Okay, commutative. What's your commute? Like, what's a commute, right? Like, I go from my house to work, and then I go from work to my house. That's my commute. I go back and forth. And the only thing that's different between going from my house to work and from work to my house is that I change directions, right? It's the same distance unless I take weird different routes every day, but we're creatures of habit. We usually go the same direction or the same path to work every day, right? So this just changes direction or changes order. And if you think about it, if I add 2 numbers together, it doesn't matter. 3 plus 4 is 7. 4 plus 3 is 7. I can change the order and it didn't change anything. Same thing with multiplication. If I multiply 2 times 3, that's the same thing as 3 times 2. The order doesn't matter. Now, this property, especially commutative, does not work with subtraction or division because the order does matter. 2 minus, or 5 minus 2 is not the same thing as 2 minus 5, right? Division, 24 divided by 2 is not the same thing as 2 divided by 24. It's the same with the associative. So you can do subtraction, but division really can't change the order, right? Because it would be different. So if you're looking at that and you say, okay, this is all in the same order, 2, 3, and 4. Well, here, let's do. Yeah, you're asked to identify what property this is. Everything is in the same exact order. The only thing that moved was parentheses. That's just the groups, so that's associative property. If you look at 2 sides of the equal and they flipped the numbers, then you know that that's commutative. Okay. Now distributive has parentheses in it. They don't really move. They go away. So if I have A, this is distributive property of multiplication over addition. What I do is I take A and I multiply it by B and I multiply it by C. So don't look at this and go, oh, associative, it has parentheses. If you look at both sides, you're seeing that the parentheses are going away. In a real world example, that would be 15 plus 180. Okay. Or we can also say you also have it over subtraction. Same exact thing except it's minus instead of plus. Okay. Distributive property is nice to make multiplication easy to do in your head.
Is that the one that the A multiplied to the B and the A multiplied to the C and then you have
Now sometimes you can't add them together. If one of mine is a variable and the other is a number, this is 3 times x and 3 times 2. So I couldn't combine that anymore because they're not like terms. But it's the same property. I'm taking that 3, and I like to draw little arrows when I'm distributing. I multiply it by both. Right, so I did this 3, I did 3 times x and 3 times 2. And it's to help you remember that's called distributive. Like I'm distributing, if I distribute papers, I give you each one paper, right? Well, I'm distributing that thing in front of the parentheses to everything inside. We can rewrite this.
how about adding them first?
Hard, commutative. We're going to change the order. That's all you have to do. You don't have to. You could also write this as n minus 5 if you wanted at that point, because plus and negative is the same thing as minus. Now, when the number comes out front, you do not need parentheses. In this case, the parentheses are necessary. Okay, so if the number is behind the letter, you do have to have parentheses. If the number is in front of the letter, you don't, because this is implied multiplication. And when you have 2 letters just sitting right next to each other, it's also implied multiplication. So if we're going to use the associative property, all we do is we move the parentheses. So instead of doing 12 plus 45 plus y, we're going to do 12 plus 45 plus y. And instead of doing 5 times and then 7w, we'll do 5 times 7 times w. So we just shifted those parentheses over. Now, again, I had to put that dot between the 5 and the 7 because if I try to write 5 and 7 for multiplication, it just looks 57. Right? So that doesn't work. Now that means we take whatever's on the outside of the parentheses and multiply it by everything on the inside. So in this case, it's 2 things. Here, I multiply it by 3 things. Okay, so 3 times x is 3x. Because, in case you're wondering why that is, there's like this imaginary 1 right there. If there's no number on the letter, it's a 1. So 3 times 1 is 3. 3 times 4 is 12. Yeah. So I do 2 times 3, so I get 6y. 2 times 5 is 10z, and then 2 times 1 is 2. Okay. Now, very important. If this number out here has a negative attached to it, when you distribute it, when you distribute in, you distribute that negative in with you. So it's negative 3 times 4, negative 3 times negative 7. Okay, so that's negative 12x and then plus 21. Okay, so don't leave those negatives behind. Right? If it's attached to whatever you're distributing, it has to come in with it. And it's negative times both, not just times the first one. Yeah, so I'm going to take that negative 8, multiply it by the 2 and by the 5.
16 plus 5.
Right? Because it's 8 times 2, 8 times 5. Here, this negative right here by itself. It's kind of like a little imaginary negative 1. So you can distribute that negative 1. Or you can think of it, so you can either think of it as negative 1 times everything, or you can think of it as the negative outside changes the sign of everything inside. Okay, so however it makes sense to you, but negative 1 times negative, that's going to be 4a minus b minus 3c. Okay, so what you do is if I have 8y and 6y, that's 8 plus 6. So that's 14y. So add the coefficients. Like that. Okay. These are the same, x squared y. I have 7 minus 10. So that's essentially what I'm doing right there, 7 minus 10. So my answer there is negative 3x squared y. Okay. Negative 15 plus 4 minus 1. Right? If there's nothing on there, it's a 1. So negative 15 plus 4 is negative 11. Minus 1, negative 12. Okay, so what you're actually doing is you're adding and subtracting the coefficients. And then the variable stays the same. Or the variable portion, because, right, this is not just one variable, it's a whole section of variables. If you want, you can rearrange them. You don't have to do this, but some people find it's useful. Okay, so 3x and 4x, those are the same. So you can put them next to each other. Okay. 8y and negative 10y, those are the same. So I can put those next to each other. And then poor little 19 is all by himself. So I'll put him all by himself. And then combine them. Now, like I said, this first step is optional. You don't have to rearrange them. Just make sure that if you don't rearrange them, that you take account every single like term that's in the whole expression. Like, don't miss something and leave it out. So negative 3 plus 4 is just 1x. 8 minus 10 is negative 2, and then that poor little negative 19 is just all still hanging out by himself. Is to combine all like terms. There shouldn't be any parentheses left in the expression when it's completely simplified. No parentheses should be left. And you combine all your like terms until you can't combine anymore. I'll just throw it in here. It's not for right now, but fractions are reduced. If there are any fractions in there, they would be reduced to be completely simplified. Parentheses first. Like I said, there's no parentheses left when things are completely simplified. So that means we need to distribute first. So I need to take this -3 and multiply it in. So I'm going to get 6 minus 6y minus 27. Okay. Now my like terms are this 6 and this -27. 6y just hangs out by itself. If you want to rearrange it, you can. But you get -21. So you can, if you want to rearrange it, this is how you would rearrange it. You don't have to do this step. You can just go from here to here if you want. Terrible drawing. An equation has an equal sign. An expression does not. What we were doing here, these are expressions. There's no equal, and you'll notice I didn't write any equals. So with an expression, the only thing you can do is simplify it. With an equation, you can solve it. The solution is the variable or the value of the variable that would make it true. Okay, so what we do is think of like the variable as like, you know, those celebrity cardboard cutouts, right? So you see this cardboard cutout, but you're looking at the back of it and you're wondering what celebrity the cardboard cutout is for. So you do some steps that allow you to turn it around so you can see the picture on the front of the cardboard cutout. That tells you your value of your equation. Does that make sense at all? It's an unknown, and we're going to find it. It's like a big giant puzzle. We're math Sherlock Holmes. Okay, but first we need to determine, is this a solution or not? 6. To determine if it's a solution, I take that 6 and I plug it in for x. So I get 2 times 6 minus 9 equals 3. Well, this is 12 minus 9 equals 3. 12 minus 9 is 3. Does 3 equal 3? Yes. So it is a solution. I take in -2 and plug it in for p. 20 is equal to 8 times -2 minus 4. So you get 20 is equal to -16 minus 4. 20 equals -20. No. So -2 is not a solution to this. Questions on that?
We're always finding something supposed to.
Linear equation gives you a straight line when you graph it, which you'll be graphing things, you know, later. But linear equations have no exponent on the variable. Okay. So it's written in this format, so it's something like this: 2x plus 5 equals 12 or something. I mean, that's a linear equation. Yeah, if you have no exponent, okay, if you have no exponent, it's the same thing as an exponent of 1. So these are the same. X to the 1 is the same thing as x because you've got 1x. Equivalent equations have the same solution. So if I have two equations, So equation 1, and I have equation 2, and when I solve them, I get the same answer. That meant equivalent, equation 1 and equation 2 were equivalent to each other. So if they have the same answer, they're equivalent, even if they look completely different. Okay, so this would be 2. Okay, if I solve both of these in both situations, x would equal 2. So these two equations are equivalent, even though they look completely different. But that's because the x is the same in both of them. And there's a symbol for equivalent. It's like an equal, but it has 3 lines. Does that make sense? Okay. It says that if I have 2 things and they're equal, I can add the same thing to both sides and it's still equal. We agree this is true, right? Likewise, if I have 2 things that are equal, I can subtract the same thing from both sides and they're still equal. Really simple example, 5 equals 5. We all agree, right? Well, if I add 1 to it, to both sides, it's still true, right? Because 6 equals 6. And likewise, if I start out with 6 equals 6 and I subtract 4 from both sides, well, it's 2 equals 2 now. So it's that the 2 sides will still stay equal.
Balance.
Yeah, in balance, exactly. All right, we are going to use those properties to solve these equations. These are single-step equations. So if I say x minus 6 equals 18, I can add 6 to both sides. The reason I choose to add is because these two are going to cancel each other out and be a 0. Right? Negative 6 and positive 6 cancel. So basically I have x plus 0 equals 24, or just x equals 24.
Oh, you doing the
You do the opposite.
simplifying, right? Like simplifying.
No, this is solving.
Solving.
So what you want to do is you want to do the opposite operation. So here I've got x minus 7. And you always want to try to get that, you want to get the x by itself. So we want to look at what's next to the x.
Is plus 7.
So we're going to do plus 7. Okay. That's going to be negative 5. Negative 7 and positive 7, they cancel each other out. So negative 5 equals x, or if you don't like that, you can rewrite it as x equals negative 5.
How about just changing the whole number sign to the other side and change the sign to the opposite?
So I'm going to trade 11 over to the other team, so he's now negative. So z equals 3.
It's so easy.
For some people, not for everybody. Or 2, it's positive over here, so to cancel it out, I'm going to subtract 2 from both sides. These will cancel. Negative 8 and negative 2 makes a negative 10 equals q. We have stuff going on each side of the equation, or the equal sign, right? What we have to do before we start adding and subtracting things from side to side, we have to combine all our like terms on one side first. That's very important, because otherwise you can start moving things and you get this big giant mess of stuff. We don't want that. So what I do is I pretend there's this wall right here, and I can't cross the wall till it's simplified. So I have negative 8 plus 3x minus 2x. So that's negative 8 plus x on this side. Then I have 12 minus 9, that's 3. Now I'm simplified. So I'm just going to rewrite it. You don't have to rewrite it. You can just put an equal sign in between them like that. But I'm just going to rewrite it so it's pretty and clear. Now I can start moving things from one side to the other. You can either just pick this up and move it to the other side, in which case it's going to be positive, or you can add it to both sides. And x is going to equal 11. Here I've got distribution to do first. So this side's not going to change, right? That's just -5. It's by itself. So 2 times y and 2 times 1, and then this minus y. 2y minus y is y. And I can either pick this 2 up and move him to the other side, in which case he would be negative, or I can subtract him from both sides. And I get -7 is equal to y. They are dividing. Don't look at this as a fraction. Don't go, oh my God, x fourths. What is that? No, this is not x fourths. This is x divided by 4. So to get rid of division, I'm going to multiply, because those will cancel. And so I get x is equal to -20. Right? This is not t -8ths. This is t divided by -8. So to get rid of that -8, I'm going to multiply both sides by -8, and I'm going to get -16 equals t. Okay? So I know that first instinct is you see a fraction, you go, ah! No. But it's not a fraction. It's not a fraction. It's division. And I know that a lot of you go, division? Oh, no. But you don't actually have to divide. So it's all good. You have to multiply. Okay. This will skip. Okay, so we do problem recognition. What do I need to do to clear that 12? Multiply. What do I need to do to this one? Subtract 18. -16. You're on it. Before I do anything at all, I got to add my like terms. So 20 plus 8 is 28. -10t plus 3t is -7t. Now what do I do? Yeah, divide by -7. And I get t equals -4. Or you could say -4 equals t. I have a tendency to go ahead and flip it because I like the letter in front. That's just me. Oops, wait, sorry. I'm putting parentheses in the wrong place. Okay, so the very first thing I need to do is distribute. And what am I multiplying by? -3. Don't forget that negative. I can, if you want, you can do this at the same time. So I'm at -3t, -6, -1. Well, 4t minus 3t is t, and -6 minus 1 is -7. Then I'm going to do what? I'm going to add my 7. So I get 13 is equal to t, or t is equal to 13. Also, I don't know if you'll notice, I'm doing this to my t's instead of this. Because if I said t plus 6, it gets confusing looking. So, like, a lot of times you curve your t so that you know it's a t. Okay. Multiple steps. We're going to do the opposite of PEMDAS. When you're simplifying, you do PIMDAS, right? So you do parentheses, but when you're doing multiple step equations, this is the one time that addition and subtraction are like all up high. Like they're like, it's like Peasants Equality Day. That only happens once a year. We get addition or subtraction first, and then multiplication or division. So first we're going to add 3 to both sides. Then we're going to divide. And why it works out that way is because what we did is we took some unknown number, we multiplied it by 2, and then we subtracted 3 from it, and it gave us 15. So to undo that, we had to add 3, then divide by 2. So you go backwards. Does that make sense? So we're going to subtract 10 first. That's going to give me 11 is equal to negative 3c. At which point you might start panicking because you're going, 11 doesn't divide by 3. That's okay. Watch what happens. Leave it a fraction. You don't have to tell me the decimal that 11 thirds is. You just leave it 11 thirds. Negatives don't go in the denominator though, so you move it out front. You just leave it as a fraction. Huh? Yeah. And let's say this 11 was already negative, and I did divide by negative 3, divide by negative 3, so I have a negative over negative.
Why do you left it as a fraction?
Because I subtracted wrong. And I was testing you to see if you knew what 22 minus 10 was. No, that's just me being at the end of the day and not knowing how to subtract 10. I'm not. Whew, sorry about that. Yeah, all right, that was not my. I have to move all my variables to one side and all my numbers to the other. So I can either, I'm going to rewrite this real quick. Okay, I can either add 2x to both sides, which will give me 6x plus 5 is equal to negative 13. And then I can subtract 5 from both sides, which gives me 6x equals negative 18. And then I divide by 6. Which gives me x equals negative 3. Or I can be in the NFL, and I'm going to trade this guy to this team, and this guy to this team. So 4x, this was negative 2x, so it becomes plus 2x. This is a positive 5, so it becomes negative 5. Okay. Huh? No, I don't trade the 6. No, I have to divide by the 6. No, I can't trade him. It's multiplication. I have to do division. I did my distribution first. Now, like I said, I can either add 4y to both sides, or I could trade him. And so I get 6y plus 20 equals 8. Subtract 20 from both sides or trade him. 6y is negative 12. No matter which process you use, whether you trade them or you do the adding and subtracting, you'll get to this part. This will be the same. Then you divide by 6. And y is negative 2. Okay, any questions on any of this? Okay, you're